Hey guys, in this section, I'm going to teach you about how to perform a traverse operation and a pop operation on the linked list. In the earlier section, I have teach about the push operation and also how to initial setup of a singly linked list. And we can now check how traverse operation is performed. We just have to write traverse, and we have to like declare a variable current, and this also points towards the head. That means now the current will be also pointing towards this data node, and we have to iterate the current through the node. Then only we get all the data or anything that we want from that node. So when we traverse through the node, we have to traverse it with a while loop. While checks if there is a current, then that means when there is a current node, it will become true and it will reach this node initially. Then after updating, it will reach here. Then it will reach here, and then finally, when it reach null, it the while condition becomes false and does not enter on that iteration. So we have to console.log it, log the current. We have to get the current dot data. We want the values like the 10, 20, 30, these values we want. And we just have to iterate. We just have to update the current equal to current dot next. That means initially we are here, and we are initially here, and both are pointing towards this node, and while current become true, that means that if there exists a node, then we print the data and we update the current towards the next node. That means the second one, and on the second iteration, the current is node, and we console the data of that, and and we update this current towards the next node. So we can check what happens when we call list or traverse. Initially, I like to clear the console and try this node index. Oh, okay. Just comment this out. Node index. We can see 10, 20, 30. That's the values of this. So traverse is working. We can now move to pop. Pop means actually popping the last node from the singly linked list. That means popping out this node from the singly linked list. In singly linked list, it's actually a one directional movement. So we only can reach the last element by traversing through that list. We can't pick the last element directly from that list. So we have to also write let current equal to this dot head, and we need to get another variable that is new tail. That means that also point to this dot head. The new tail means we want a uh, new tail 30 will get eliminated, and we want 20 to become the new tail. You just have to consider this example in which both the new tail and the current are pointing at the 10, and uh, on entering the while loop, while if there exists a current, then we have to say like new tail will become the current, and current get updated to current dot next. This means that both the new tail and current are pointing initially at the 10. Then we have to on the second iteration, the current will become 20, and the new tail uh, will be uh, at 10, and on the third iteration, it moves. Okay. Let me tell again that on the first iteration, both the current and the new tail. No, not the first iteration. When we are first initializing both the stored head and the stored head to current and new tail. And on entering the while loop, new tail becomes current. That means both are pointing towards the same 10. And like on executing the while loop, the new tail become current. That means both it are pointing towards the 10, and the current will become current dot x. That means it reaches it becomes 20. And on the second iteration, there exists a current, so it enters the loop, and the new tail will become the current. That means new tail will be also moving towards here. Now both points toward 20, and this line current equal to current dot next. That means current will get updated to here, and it again enters this loop, and the new tail will become the current. Here is the problem that now both are pointing towards 30, but we want new tail to be 20. So we have to uh, update this condition to this dot next. That means uh, on second iteration, the current will be here, and the new tail will be there, and on the on the first iteration it will be like this, and on the second iteration new tail will become current. That means new tail will be here, and the current will be also been updated when current equal to current dot next to this. On reaching this, we are checking whether there exists any other node, like it literally pointing towards null. So we check whether there exists anything of this dot node next. That means 30. Like the we have considering the 30, and we are checking whether there exists any dot next. No, we are literally pointing towards null. So we are setting neutral towards current. That means neutral is become 20. So we have to this dot we have to make that this total is pointing now towards 30. We have to reinitialize it towards 20. So new tail, that means new tail is here 20. So this dot tail become new tail, and we have to disconnect this node. So we have to write this dot tail dot next. There is no next. We are writing there is no next, and also we are decreasing the length because here we say the length will get updated on push, and so when we are popping, we have to decrease the length. And I think that's all for this. We can check this out. Let's write list dot pop. We can see what happens. We can now see the 30 get eliminated, and there exists only 10 and 20. If you want the node that got eliminated, if you want to get the last element which got eliminated, you just have to return the current, because the current now points toward the last node. Uh, you just have to reconsider how the loop iterates, because we stop at the last element and it checks whether there exists any next. There doesn't exist any. So the current still now point towards the last element, and new tail points towards the element that just in front of that the last element, that is 20, and the current is now 30. So we just have to return the current, and we can print it out console.log list dot pop. We can see which element is there. We can see this element got eliminated, and we can actually like pop out the last element and traverse the list to just check whether it exists. So there exists only 10 and 20, and the 30 got eliminated. That's how the pop operation is performed. In this, you just have to understand the concept of current dot next. I think you all got how it works. We are initially we are at the 10. Both the current and the new are pointing at the 10, and on the first iteration, We just update the current towards here, and new tail is still pointing here. And on the second iteration, we forward, like we update the new tail to current, and current that updated to current dot next, and we check. And after that, we check whether there exists any current dot next. That means exist any other element, and the condition become false. And current is at 30, and the new tail is at 20. And we set this tail as new tail because we want to eliminate this element, and this tail now points at 20. And we just like disconnected that node by saying this tail dot next, that means 30 equal to null. That means we just disconnected that, and we like decrease the length. Yeah, you just have to like understand that concept. That's all about it. If there's also one condition where will not be there, so you also have to consider the head, whether if there won't exist any element, there won't be any head or tail. So we have to check that if the store length is now equal to 0, that means there won't exist any node. So we have to say the store head now also point towards null, and the stop tail also points towards null. This condition can also arise. So I'm explaining it one more time that it means uh, there can be occasions where we popped out all the elements and the list become null. That means there won't be existing any elements. So we are setting that the store head to null. That means the store head is now pointing towards nothing because there's nothing on the nodes, and the store tail is also pointing to a nothing because there exists no node at that condition. Okay, that's all about pop. And on the next lecture, we can meet, and I'm going to be teaching about shift, unshift, set, and get operations. Okay, that's all about this video. Thank you guys.